a sea predator with a jackknife head that hunted the oceans 508 million years ago, was the earliest relative of today's crabs and spiders. The long-extinct species Habelia optata was about 2 centimetres (0.8 inches) long, with a tail as long as the rest of its body. Scientists have now re-evaluated the tiny, yet exceptionally fierce species, finding it belongs to a group of invertebrate animals known as the arthropods. This means the ancient creature is a close parent of familiar creatures such as spiders, insects, lobsters, and crabs. The research illustrates that the well-armoured body of Habelia optata, covered in a multitude of different spines, was divided into head, thorax and post-thorax, all bearing different types of appendages. The thorax displays 5 pairs of walking legs, while the post-thorax houses rounded appendages likely used in breathing. The head of Habelia contained a series of 5 appendages made of a large plate with teeth for mastication, a leg-like branch with stiff bristle-like spines for grasping, and an elongate, slender branch modified as a sensory or tactile appendage. The researchers conclude from the outstanding head structure, as well as from well-developed walking legs, that Habelia optata and its relatives were active predators of the Cambrian sea floors, hunting for small shelly sea creatures, such as trilobites. Habelia optata has confounded scientists since it was first discovered more than a century ago. It lived during the Middle Cambrian period around 508 million years ago and comes from the renowned Burgess Shale fossil deposit in British Columbia. The species was part of the Cambrian explosion, a period of rapid evolutionary change when most major animal groups first emerged in the fossil record. Like all arthropods, Habelia optata features a segmented body with external skeleton and jointed limbs. But what remained unclear for decades was the main subgroup of arthropods to which Habelia belonged. Early studies had suggested mandibulates, a diverse lineage whose members possess antennae and a pair of specialized appendages known as mandibles, usually used to grasp, squeeze and crush their food. Habelia was later left as one of the unresolved arthropods of the Burgess Shale.But. The new analysis from experts at the University of Toronto, Canada, suggests that Habelia optata was instead a close relative of the ancestor of all chelicerates, the other subgroup of arthropods living today. The group is named after the presence of appendages called chelicerae in front of the mouth and used to cut food. Study lead author, Dr. Cédric Aria, said, Habelia now shows in great detail the body architecture from which chelicerates emerged, which allows us to solve some long-standing questions. We can now explain why, for instance, horseshoe crabs have a reduced pair of limbs, the chelicerae, at the back of their heads. Those are relics of fully formed appendages, as chelicerates seem to originally have had heads with no less than 7 pairs of limbs. The researchers analyzed 41 specimens in total, the majority of which are new specimens acquired by fieldwork parties to the Burgess Shale. The research illustrates that the well-armoured body of Habelia optata, covered in a multitude of different spines, was divided into head, thorax and post-thorax, all bearing different types of appendages. The thorax displays 5 pairs of walking legs, while the post-thorax houses rounded appendages likely used in breathing. Dr. Aria said, scorpions and the now extinct sea scorpions are also chelicerates with bodies divided into 3 distinct regions. We think that these regions broadly correspond to those of Habelia.But. A major difference is that scorpions and sea scorpions, like all chelicerates, literally walk on their heads, while Habelia still had walking appendages in its thorax. The researchers argue that this difference in anatomy allowed Habelia to evolve an especially complex head that makes this fossil species even more peculiar compared to known chelicerates. The head of Habelia contained a series of 5 appendages made of a large plate with teeth for chewing, a leg-like branch with stiff bristle-like spines for grasping, and an elongate, slender branch modified as a sensory or tactile appendage. Dr. Aria added, this complex apparatus of appendages and jaws made Habelia an exceptionally fierce predator for its size. It was likely both very mobile and efficient in tearing apart its prey. The researchers conclude from the outstanding head structure, as well as from well-developed walking legs, that Habelia optata and its relatives were active predators of the Cambrian sea floors, hunting for small shelly sea creatures, such as trilobites. Study co-author, Professor Jean-Bernard Caron, added, the appearance and spread of animals with shells are considered to be one of the defining characteristics of the Cambrian explosion. Habelia contributes to illustrate how important this ecological factor was for the early diversification of chelicerates and arthropods in general.